All right, so now we're going to talk about symmetry, and we're going to talk about different figures. So a figure has line symmetry if it can be mapped onto itself. So mapped onto itself by a reflection. So these are all like we're talking about a figure has or a figure can. So the line of symmetry is actually the line of reflection. Rotational symmetry is when a figure can be rotated and mapped back onto itself in 180 degrees or less. So a figure can be mapped onto itself with a rotation, and this is where you have to be careful, a rotation of 180 degrees or less. So it can't even be like 181. It's got to be 180 or less. Now, we're not going to be worried about this, but also like when you're determining rotational symmetry, it can be found, so this can be found either clockwise or counterclockwise. All right, so when we rotate things around the coordinate plane, we always go counterclockwise. But when we don't have things on the coordinate plane and we're just talking about images and figures, we can turn them either way to determine rotational symmetry. So let's look at these. Identify the lines of symmetry. So remember, a line of symmetry is kind of like if you folded it up, if you folded the piece of paper, where could you fold it so that it's its exact replica of itself on both sides? So we have a rectangle here. If we draw a line here and here, then, all right, it would have two lines of symmetry. We look at this pentagon, and I want you to kind of note, I'm going to go ahead and tell you that, yes, this is a regular pentagon. So if it's a regular pentagon, since it has 5 congruent sides, that's how many lines of symmetry it's going to have if it's regular. So 1, you can go through all the vertices, 2, 3, 4, and 5. So any regular polygon, however number of sides, that's how many lines of symmetry it's going to have. C is not regular. So this one can only really be split right down the middle, so it's going to have 1 line of symmetry, and because this is not regular. All right, identify rotational symmetry. Does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. So remember, this must be 180 degrees or less for us to say, yes, it does have rotational symmetry. So a square. Well, if you think about a square, right, it has 4 congruent sides. So if you turn the square just 90 degrees, it's going to look exactly the same. So the square does have rotational symmetry, and it will map back onto itself in 90 degrees or 180 degrees. So remember, we don't care about anything past 180. So a square has 90 or 180. Now a little trick is, remember, there's 360 degrees total it can turn. Well, since it has 4 congruent sides, if you divide 360 divided by 4, that's going to give you 90. So look, here is the 90, and look at the rotational symmetry is 90. So if there are congruent sides, you can also use the number of sides to find the rotational symmetry, just like we did the line of symmetry. So you can see here, it tells you it's a regular hexagon, which means all the sides are the same. So since all the sides are the same, we can take 360 and divide it by 6, and that's going to give us 60 degrees. So the regular hexagon does have rotational symmetry, and each 60-degree turn, so this means every 60 degrees up to 180, it's going to map onto itself. So you can say at 60 degrees, it'll map onto itself, 120, it'll map onto itself, and 180, it will map onto itself. Now looking at the kite. The kite here only has one line of symmetry here. And the kite being unproportionate as it is, it's not going to have rotational symmetry because it takes 360 degrees to map back on itself. You must turn it all the way around, and that doesn't work for us. It must be 180 or less. All right, identify the symmetry. So we're going to look for line symmetry and rotational symmetry. So if you look at this figure, you can see, okay, well, I can split it right there and right here, as you can see in the picture. So the figure has line symmetry. It has two lines of symmetry. The figure with however many lines of symmetry. So if you take however many lines of symmetry you have, so again, we're going to take 360, and if we divide it by the lines of symmetry, which they're calling S, we're going to get the rotational symmetry. So if you take 360 and divide it by the lines, in this case we have 360 divided by 2, so that's going to give us our rotational symmetry of 180 degrees.